With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Our question is, fluorine is more electronegative than either boron or phosphorus. What conclusion can be drawn from the fact that BF3 has no dipole moment but PF3 does? So over here we are supposed to tell that why BF3 does not have any dipole moment whereas PF3 does have a dipole moment. So first option is saying BF3 is not spherically symmetrical but BF3 is, right? Then they are saying BF3 molecule must be linear, atomic radius of phosphorus is larger than the atomic radius of boron, or the BF3 molecule must be planar triangular. So we have to give the reason that why BF3 is non-polar and PF3 is polar. So if we talk about dipole moment, what is dipole moment? Dipole moment gives us the idea of polarity in a particular molecule. So if we talk about BF3, we're gonna use our formula half of V plus M plus the charge if it's a anion minus the charge if it's a cation to find out the hybridization and the structure of BF3. Over here we are the number of valence electrons of our central element, then M are the number of monovalent atoms attached to the central element. If it's an anion, we need to add that charge and subtract if it's a cation. In case of BF3, our central element is boron, so we have half of number of valence electrons of boron are 3. Then number of monovalent atoms attached to it is 3. We have 3 fluorines attached to it. Now it does not have any charge, so this would be it. 6 by 2 comes out to be 3. So that means this is a sp2 hybridized molecule. Over here we can see that its steric number is 3 and we have 3 bond pairs. So we have 3 bond pairs, that means we're gonna have 0 lone pair. So this would be what? This would be trigonal planar, right? This would be its structure. We have fluorine, fluorine and fluorine, right? Now over here if we look at our individual bond dipoles, individual bond dipole is always from a less electronegative element to more electronegative element. This is more electronegative element, so we would have directions like this. Now in this case the resultant of these two would cancel out this one. So individual bond dipoles cancel out each other and hence we can say that this is a non-polar molecule, or we can say that this has a net dipole moment of 0, right? If we talk about PF3, in case of PF3 we have central element as for phosphorus and it has 5 valence electrons, then 3 monovalent atoms are attached to it, right? And then it does not have any charge, so this would be it. It would be 8 by 2. This comes out to be 4. That means its steric number is 4. So it would be what? It would be sp3 hybridized, but over here we have 3 bond pairs, right? And that means we're gonna have 1 lone pair. So its shape would be pyramidal. Its shape would be pyramidal. So if we draw its structure, we have phosphorus, then we have 1 lone pair and we have 3 bond pairs with fluorine like this. Over here if we draw the individual bond dipoles, over here it would be towards lone pair, it would be towards fluorine, again towards fluorine and again towards fluorine. Now over here the individual bond dipoles are not cancelling out each other, right? So the mu net is non-zero, or we can say that it has some dipole moment with it, right? Whereas BF3 did not have any dipole moment, right? Now if you look at our options, first is saying that BF3 is not spherically symmetrical. That is not correct. It is spherically symmetrical molecule, right? So this is not a correct statement. Second is saying BF3 molecular must be linear. This is not linear, this is trigonal planar. Then third is saying the atomic radius of phosphorus is larger than the atomic radius of boron. Now this is not relevant with respect to dipole moment because it has nothing to do with dipole moment. Atomic radius does not define the dipole moment. So this is also not correct. Fourth is saying BF3 molecule must be planar triangular. This is correct. Because it was planar triangular, its individual bond dipoles cancel out each other properly because it was a symmetrical trigonal planar molecule, right? And hence it did not have any dipole moment. So our answer to this question is option number 4th.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.